Okay, welcome back from break. So, we are going to be moving forward with our rational functions unit and be moving toward a test. Who knows how that's going to work, but we're going to figure it out together. Okay, so we're going to kind of review everything that we've done so far, just briefly, and then we're going to go into the new stuff, which is pretty light for today. All right, so before everything started, the very first thing that we did with rational expressions is simplifying them, okay? This was the very first thing that we did. So if I've got these two fractions and I'm multiplying them together, okay? You remember what you should always start by doing is factoring. So we're going to say y minus 2, maybe, times y plus 2 over y times y minus 2 times y over, okay, factors of 16 that add to be 10. That should be 8 and 2. So we have y plus 2 and y plus 8. Alright. So let's see what we've got here. Okay, these things are being multiplied together, so anything that's on both top and bottom can cancel out. So we've got a y plus 2 and a y plus 2 that cancel. We got a y minus 2 and a y minus 2. And we even have a y and a y. Alright, so the only thing left on top should be 1. On bottom, we just have a y plus 8. Okay? We were pretty good about that. That's not too hard. Now looking at this next one, we're multiplying them together again. Let's see. I actually want to make this division, so if you would correct that with me. Let's say divides. Okay. So if I'm going to divide these things, the first thing that I should do is flip them. So I need to flip that second fraction. And now I'm going to be multiplying my two fractions. Now I can go ahead and factor this bottom one that's now on top. That's going to be x plus 3, x plus 2. Over, okay, we've got 6x to the 4th. Alright, so now let's see what happens. I've got an x squared up here. That's going to take away 2 of those and leave me with an x squared on bottom. I have an x plus 2, I have an x plus 2. And I have a 3 and a 6, it's going to leave a 2. Alright, so we are left with x plus 3 on top and a 2x squared on bottom. Yeah, that's close enough to it too. Alright. No, I don't want to insert text. Alright, that wasn't too bad. So we just went through, multiplied, and divided them. Next thing we did was we went on to graphing. Now we did this by finding asymptotes and intercepts and holes and extra points. And with our asymptotes we had vertical and horizontal and slant, and there were all these rules, okay? So I know that's going to be a little bit fuzzy coming back. We will go over all of it again whenever we review, okay? But today we're going to graph just a pretty basic one. Now, if you remember, we did a lesson on crossing the horizontal asymptote and the need for that. For the purposes of the rest of this year, we're just going to forget about that, okay? So we're just going to stick with just being able to graph the most basic ones. So let's do that. So the very first thing we did with these things is factored and canceled. So if I factor that top, I'm going to factor out a 2x and be left with x minus 3. On bottom, I can't factor anything out, but I can factor that into x minus 3, x minus 4. Okay, so cancel the x minus 3's, which means there is a hole. I'm left with 2x over x minus 4. Okay, now comes the fun part of getting to pick up all of our stuff. So Vertical asymptote is whatever makes the bottom 0. So that is at x equals 4. Remember, a vertical asymptote you always write as x equals. Okay, horizontal asymptote. So the degree on the top is 2, bottom is 2. So they're the same. So we do the ratio of their leading coefficients, which is 2 over 1. So y equals 2. Okay. Let's see, we do have a hole. Now we cancel out a 3, so that means that's going to be our x point. But now we've got to find f of 3 to get our y point. So we have 2 times 3 over 3 minus 4. That's going to be negative 6. So the hole is at 3, negative 6. Okay. X-intercept is going to be whatever makes the top 0. That looks like it's going to happen at 0, 0. Which means we also have a y-intercept of 0, 0. Okay. So let's put all this crud on a graph. Let's go back over here. We are going to have a vertical asymptote at x equals 4. A horizontal asymptote at y equals 2. A hole at 3, negative 6. So right here. Okay, and then x and y intercept both right there. Alright, so we've got a really good idea of what's happening on this side. But it's a little more challenging to see what's happening on the other side of the graph, okay? So what we're going to do is we're going to find an extra point. Okay, so we're going to plug in 5 and see what happens. So f of 5, so that's 2 times 5 over 5 minus 4. So that's 10. Oh, great, that doesn't fit on my graph, but it's somewhere up here. And so here we go. Okay, hopefully that's easy enough. We remember that basic process, but again, we will go over that much more in depth when we start reviewing all of our stuff. Okay? Alright, let's move on. So, the last thing we did before break was long division with these polynomials, and using that to find slant asymptotes. So let's get into that. So if we're going to do long division, let's zoom in first. Okay, if we're going to do long division, we're going to set up the x squared minus x plus 1 on the outside. On the inside, that's not going to work, is it? Let's try that again. Move it down a little bit more so I have some more room. So x squared minus x plus 1. And then I've got x to the 4th minus 3x cubed plus 2x squared minus x plus 1. Alright. So if you remember, this is kind of just like long division you learned a long time ago. Okay, so you're trying to divide the x squared into all the stuff that you have, okay? So if I divide x to the 4th by x squared, I get x squared. So I'm going to line up my x squared term over here. So x squared times x squared is x to the 4th. X squared times negative x is negative x cubed. X squared times 1 is x squared. And then we have to subtract all of these things. So we have to change the signs. So that cancels. That makes a negative 2x cubed. And that makes a plus x squared. Okay, just like with old long division, we're bringing that down. So minus x. All right, now we do it again. If I want to divide x squared into negative 2x cubed, I'm going to get just negative 2x. Okay, so then I'm going to multiply that to my 3 original terms. and I get negative 2x cubed. Then I'm going to get plus 2x squared, so 2x squared. I'm going to get a negative 2x. All right, flip your signs and subtract. So I get negative x squared plus x. Bring down that 1. And lastly, do it one more time. So if I need to divide negative x squared by x squared, I just get negative 1. Multiply that 3, you get negative x squared. You get x, and you get negative 1. Now, change the signs. That cancels, I'm left with 2. So my answer is this x squared minus 2x minus 1 plus 2 over x squared minus x plus 1. There you have it. Okay, y'all were doing pretty good with all this stuff before break, so I think that you are going to be okay with that. If not, you can always go back on Veracross and watch those old videos and look at those old worksheets and all that kind of stuff if you're not okay with it, okay? But also, I'm here to help if you're not. All right, so that's all that we've done so far with rational functions. It's not too much, but we spent a long time doing it with all the craziness happening, so it is what it is. So today we are going to add a new skill, which is adding and subtracting these things. Okay, so essentially we're pretty much just going to have 2 or more fractions that we're adding or subtracting. Okay, so when we add and subtract functions or fractions or add or subtract anything with a denominator, we need a common denominator. Woohoo, everybody's favorite. We need a common... Ooh, that's not going to work for me, is it? Let's try this. We need a common denominator. Maybe. Minitor. Okay. So let's get into it. So here we go. Now looking at these two things, we need to first think about, do we have a common denominator? Well, I'm adding something with a 4x on bottom to something else with a 4x on bottom, so I'd say, yep, we do have a common denominator. So let's add these two functions. So this is going to be 3x, well, maybe 3x minus 8 minus x plus 8 all over 4x, because when you add fractions, you just add their numerators. Okay, so I have a negative 8 and a positive 8. 3x minus x is 2x. So this is 2x over 4x. All right. Now this simplifies. The x's drop. And 2/4 is just 1/2. Sound good? All right, now obviously I am not going to require you to do this step every time. Okay. But just to kind of show my work the first time, see where we're going, I thought that might be a good idea. All right, so let's move on. All right, this one does not have a common denominator. Remember, what you can always do, if you're unsure of that first one, put it over 1. Okay? So our common denominator here, the easiest way to get that is to just multiply the two denominators together. So our common denominator is going to be x minus 9. Now, in order to do that on the left term, there's the 7, I have to multiply by x minus 9 on top and by x minus 9 on bottom. Okay, and then minus 4 over x minus 9. Okay. So on top, I get 7x minus 63. On bottom, I get x minus 9. And then minus 4 over x minus 9. All right, and then just subtract the two fractions, and you get 7x minus 67 over x minus 9. There you have it. Okay, a lot of times with these things, guys, you're not going to get something nice and pretty like 1/2 like we did on the last one. It's kind of nice when you do, but it's honestly not really going to happen that frequently. Okay, all right, next one. All right, so now they're starting to get a little more complex, and it's kind of hard to tell what you need to do without completely being able to factor the denominators, okay? So if I take this, I am already factored on this left side, so x minus 1 over x minus 2. There's really nothing to do there. Minus, but this one, the top I'm going to leave just because it'll be easier to add that way, or I guess in this case subtract. Okay, but the bottom factors into x plus 6, x minus 2. Okay. So what this shows us is that we've already got this x minus 2 in common. Okay? The thing that we don't have on our left fraction is the x plus 6. So I'm going to have to go over to this fraction and multiply the top by x plus 6 and the bottom by x plus 6 to get that common denominator. Okay? Oops. Well, that's great. Oh, got it. Perfect. Thank you. Let's go purple, and let's do this. Oh, good. It took me all the way to the top. I love technology. Okay. There we go. How much space do I got? Perfect. All right. So now what we're going to have to do on top is FOIL these things. Okay, so I get x squared minus x plus 6x minus 6 over x squared plus 4x minus 12 minus x squared plus 4x plus 4 over x squared plus 4x minus 12. Now you could also leave those denominators in completely factored form. Either way works. I might regret not doing it that way at the very end, but let's see what happens. All right, so now I've got these two things with the same denominator being subtracted. Okay, so we can just subtract their parts. Now, be careful. This negative goes to all of this. So what are we going to have to do? We are going to have to distribute it to each and every part. Okay, so I have x squared plus 5x minus 6 minus x squared minus 4x minus 4 all over x squared plus 4x minus 12. So combine your like terms, the x squareds drop. You're just left with x, looks like minus 10 over, maybe, there we go, x squared plus 4x minus 12. There you have it. Okay, let's move on. All right, so on this one, we have things to factor on both sides. So this is x minus 4 over x plus 3 times x plus 1 minus x minus 1 over, that factors to x plus 3, x minus 3. Okay, so in this case, we need something in both fractions. In our left fraction, we are going to need to multiply by an x minus 3. In our right fraction, we're going to need to multiply by an x plus 1. Okay? So let's do that. So I'm going to get x, what did I say, minus 3 on this side, times x minus 4 over x plus 3, x plus 1, x minus 3, okay, minus this fraction. So I'm going to get, whoa, I don't want to do that, okay? I'm going to get x minus 1 times an x plus 1 over x plus 3, x plus 1, x minus 3. Okay. So if I FOIL out those numerators, I get x squared, I'm going to do this quickly, minus 7x plus 12 over all that crap. So x plus 3, x plus 1, x minus 3. Okay. Minus, okay, on this one, no, stop it. Okay, on this one, we're going to have, that's the difference of squares, so it should just be x squared minus 1 over all the crap. Okay, let's actually subtract our parts. So that's going to be an x squared minus x squared. So those are going to drop. So I have negative 7x, and that's 12 minus negative 1, so that's plus 13. All over x plus 3 times x plus 1 times x minus 3. Oof. Aren't these fun? Don't worry, the homework does not have very many on there. Okay. Now, yeah, okay, good. I was going to say, let's do one of these. Which one looks harder? Let's go with number 6. Okay. It's just like being back in the real classroom. I don't do all the examples because I am lazy. Okay, here we go. Crap. I don't want to go back to the top. I promise I'm better at technology than this. I just have fat hands that can't handle iPads. Okay, so this one, I have 1 over, that's going to be x plus 3 times x plus 2 minus 2 over, that's going to be x plus 2 times x plus 1 plus 1 over, that's going to be x minus 4 times x plus 1. Okay, so let's see. We have an x plus 3, x plus 2, got an x plus 1, and we got an x minus 4. Whew, okay, so it looks like our big old common denominator is going to have 4 different sets of parentheses. How fun. Okay, so let's just get straight into it. So this first one has the x plus 3 and the x plus 2, but it's going to need an x plus 1 and an x minus 4. Okay, so this is going to be x plus 1. I'll put an equal sign out here. X plus 1 times x minus 4. Okay, this second one is going to need a, let's see, it's going to need an x plus 3 that it doesn't have on bottom, and it's going to need the x minus 4. Okay, and this last one, it has a minus 4, but it does not have an x plus 3. Don't know why I did that. X plus 3, and it does not have an x plus 2. Okay, I think we did it. Now that's all going to be over our big old common denominator of x plus 3, x plus 2, x plus 1, x minus 4. Okay? Alright. Let's FOIL these things out. So this is going to be x squared minus 3x plus, whoa, not plus. Let's undo that. Minus 4. Minus 2 times x squared minus x minus 12 plus x squared plus 5x plus 6 all over this big long mess. Okay. All right. Now finally, let's go through. Okay, we're going to distribute that. So we've got x squared minus 3x minus 4 minus 2x squared plus 2x plus 24 plus x squared plus 5x plus 6 all over x plus 3, x plus 2, x plus 1, x minus 4. Last step, I promise. Okay, let's go through each of our individual parts. So I have an x squared, a negative 2x squared, and an x squared. Those all cancel. How nice. Okay, I have a negative 3x plus a 2x, so that's just negative x, plus 5x, so negative x plus 5x is 4x. Okay, and lastly I have a negative 4 plus a 24, so that's 20, plus 6, so plus 26. Is that right? Yep, plus 26. All over x plus 3, x plus 2, x plus 1, and x minus 4. Okay, I promise there's a reason for this, at least, you know, in terms of math. Probably not the real world, but we've had those discussions. Okay, so there is a reason for this. Next time we are going to be solving equations, and you have to do this, now granted, usually on a smaller scale, but you have to do it. Okay? So if you need them, here are little steps for you. Okay? But if not, go on to the worksheet